Sweet. Amber Dynamics is looking to build a security robot. Security is really expensive. You can't always have Mo around to guard your back. In fact, one day of security, 365 days a year, costs $200,000. So they want to build a security robot. Imagine R2-D2 with the personality of Robocop. Needs to be able to navigate indoors and outdoors and not run over that kid that just fell with a stroller. In response to Amber's request, this is our project, Project Copal. We broke our project down into 3 stages. First is the motion control system, which will be controlling the existing platform that they have provided to us. Our second phase is the autonomous navigation. Basically, it needs to know where it is and be able to navigate through an environment. And this third stage is collision avoidance. We really don't want to run over that kid that fell on the floor.
So, the very first phase of the project, motion control, we have already begun. We need motion control because the existing system that came with the platform we are using is proprietary, and we do not have access to modify it or use it in any way. So we had to basically start from scratch. So we are going to design a printed circuit board. That printed circuit board is going to be an all-in-one solution that will allow us to drive the base without having to have any other external controls. It will act as its own standalone black box system. We're going to use an MSP430 controller. This is because we are familiar with it and we have deemed it to be good enough for our purposes. And we're going to try and add some advanced motion features such as dynamic braking if we have time. However, we already have basically finished the first phase. We have the platform wheeling around successfully, and all we have to do is make the printed circuit board, have it fabricated, tested, and delivered. And we believe that we will be done first phase 100% by the end of next month.
Phase 2, the navigation. This is the key problem of this project. Basically, we need to know where we are, know its position in real time. We need to be able to then navigate so we can get around, and we need to have some sort of system to do this. There's a few ways to do positioning, such as IMUs, but we decided to go with the best solution we could find, which is Dragonfly. We reached out to Accuware out of Florida, and they very graciously gave us a full license to their technology. Now, Dragonfly uses standard cameras, so instead of having to spend $10,000 on a camera, we can use $100, $200 cameras to be able to accomplish this. Now, it works with something called SLAM. Essentially, it creates a point cloud with parts of its environment through the cameras. As it's doing this, it saves these points and creates a map in real time. So basically, as it's moving around, it's finding these points and it's creating a map. With this, it's able to give centimeter level accuracy, indoors and outdoors. Simply, the inputs are 2 cameras, and it outputs either X and Y relative to a home position or GPS coordinates. Once we have accurate positioning data, we'll be able to navigate the environment. What we plan to do is create paths with the existing teach pendant. Just all we need to do is record our data and then simply follow those paths around. On top of this level will be a computer running Linux, which is what the native app runs on. We'll have quad-core processing because there's a lot of data that it needs to analyze. And this level will be on top. It will communicate serially with the MSP, which will be controlling our motors. The expected cost for this is about $1,000, 500 of which will go to the computing unit. The other 500 will go to the cameras on the unit.
So the final phase of the project is the collision avoidance. Safety is very important, especially with a platform as heavy as this. Our plan is to create a suite of sensors that will detect a region around the robot so that in the event something goes into a dangerous zone, a hazard of any kind, it will automatically override any and all controls and immediately cease motion of the robot and initiate braking. This system will be very low level. It will override all other systems except for manual control. It will have full override capability at all times. As you can see, we are going to architect it so that there is a region in front of it, giving it time to brake if it is in motion, and it's going to have a region all around it to prevent any kind of close hazards that the cameras will probably not be able to detect. We are going to expect many kinds of challenges, and Jamie is going to talk about those.
First thing, integrating Dragonfly. Now, Accuware has provided us really great support. There's a lot of documentation. It is a native Java app. The first challenge is to basically integrate it, get some cameras, get it working together, make sure that we are where it actually says we are. And then we need to create that navigation system, make sure it integrates with the data that we're getting from Dragonfly. Another challenge is integrating the CAS. So the top level system is telling the robot to go. We need to stop when the sensors tell it to stop. And pulling it all together, making sure that we have something that can navigate around and get from point A to point B. After all this is done, we do plan to have this robot by the end of April that can navigate its environment, get to point A from point B, and maybe save a few kids along the way. Thank you.